Here's problem 2617. In the figure, if C is equal to 5 microfarads, C2 is 15 microfarads, C3 is 30 microfarads, and the voltage of the battery is 24 volts, what's the potential difference across C2? Now we can see we have a voltage of the battery, and we have two branches that are in parallel with the battery. So we know that there's 24 volts across C1, and there's 24 volts across C2 plus C3. Now, as the voltage drops go down, then there will be two separate voltage drops, C2 and V2 and V3 across C2 and C3 respectively, will add up to 24 volts. But we don't know specifically what is the voltage across each of those capacitors. But what we could do is find the charge on those capacitors and then figure out the voltage on each of them. So that's what we're going to do. Let's find the equivalent capacitance of this series combination here. Well, it'll be product over the sum since there's only two of them, and so we'll have 15 microfarads times 30 microfarads over 15 plus 30 gives us 450 over 45 or 10 microfarads. So if I were to rewrite this circuit, it would look something like this. We'd have C1 on top, which is 5 microfarads. We'd have a equivalent capacitance in the middle of 10, and then we'd have our battery of 24 volts. Now this 24 volts is across the 10 and across the 5 because everything's in parallel. So we know that there is 24 volts across this 10 microfarads here. And hence we can find the charge on that series combination. Charge equals capacitance times voltage. So that would be 10 microfarads times 24 volts, which will give us 240 microcoulombs of charge on that middle branch. But we know that capacitors in series have the same charge, and they have the same charge as their equivalent capacitance. So it's true that the charge on capacitance 2 is equal to the charge on this series that we just figured out, and that should equal 240 microcoulombs. So now we know the charge on C2 right here. Since we know its charge, we can calculate its voltage, because since Q equals CV, the voltage on number 2 will equal its charge, Q2, divided by its capacitance, C2. So that is going to be equal to 240 microcoulombs over 15 microfarads. The micro and the micro will cancel out, and 240 divided by 15 is 16 volts. So the voltage on capacitor C2 is 16 volts. That would mean that the voltage across C3 would be 8 volts, so that could add up to 24. Note how the ratio of the capacitance is opposite the ratio of the voltages. Since C2 is 15 and C3 is 30 microfarads, that's a 1 to 2 ratio, but the voltage goes as 16 volts to 8 volts, 2 to 1 in the opposite direction. So that's our answer. V2 is 16 volts.